All right, ladies and gentlemen, here we're going to consider the extreme value theorem, which says that as long as a function is continuous on an interval a to b, then it has both a maximum and a minimum value on a to b. So we've worked with maximums and minimums already a little bit. All this is saying is that if a function is continuous, then that maximum and the minimum is guaranteed. If it has like an asymptote or something, it may or may not have a maximum or minimum. So just like the intermediate value theorem, it guarantees an existence, but if the condition is not met, it doesn't necessarily guarantee that there is no maximum. What we're going to do here is we're going to consider sort of a real-life example. And notice we have the same kind of closed interval as we do in the theorem, right? The brackets and the less than or equal to mean the same thing. So we're going to consider how to use this idea of an extreme value. And in the text, we're talking about like finding maximums and minimums of a stock price. Because you want to sell at the maximum to get the maximum amount of money you have, or you want to buy at a minimum to get the best price, right? From our work before, we know that we need, for a maximum or a minimum, we need a critical value, and that would be where s prime of t does not exist or is equal to 0, and here we're going to be looking for zeros, so we're going to need to find s prime of t. And this is just a power rule one. I can do this without a calculator. I'm going to leave that 0.2 factored out. And then power rule on the inside would give me 2t squared minus 41t plus 90. And then the derivative of the constant is 0, right? So there's my derivative. And then if I'm asked to find a maximum of s of t, what we need to do here, a relative maximum, I should say, is we need to set our derivative equal to 0. So I'm going to be like, okay, 0 is equal to 0.2 times blah, blah, blah. I can divide out that 0, and then I can factor. This one's kind of a hard one to factor. If you got stuck here factoring, that wouldn't be the worst thing in the world. It factors like so. So that negative 5 times negative 18 is 90, and then 2 times negative 18 is negative 36, minus 5 is our negative 41t. And then my zeros, right, are negative 18 and 5 over 2. And if I wanted to make a sign chart then, my sign chart would be like so. We only really care about positive values of t. 5 halves is here. And then 18 is way up here. And I did this work already. We get positive interval here, a negative interval here, and a positive interval here. So my maximum value is right here, right? This is my maximum because s prime goes from positive to negative. And then the value the stock obtains at this time, right? Well, that's going to be s, right? So t equals 5 halves is my max. And then s of 5 halves would be this s, right? So I'm going to plug it back in there, and that spits out, and this I'm just going to do in my calculator, 251.458. And what I did here, just to be clear, is I took my original function, and every time I had a t, I took it out, put in that 5 over 2 that we got as our maximum to get that value. So $251.46, we would say, is the maximum, the relative maximum price. Now we have a different question. What is the absolute highest value the stock attains in February? Okay. So here, right, we could have a couple of different things happening. We could have a situation where that t equals 5 over 2 is our maximum. Or we could have a different situation where maybe it started at a very high price, hit a minimum, came back up, and here we'd have t equals 5 over 2. But it would actually be better to sell the price right here at the beginning of February. Because all we've done so far, if we've shown that the derivative of s changes from positive to negative at t equals 5 over 2, we don't know that it's the biggest value. So to do this, we need to check 3 values here. We need to check t equal to 0, t equal to 5 over 2. And we don't need to check 18 because we saw that 18 is a minimum, but we do need to check t equals 28. And where did I get those values? well, they're the beginning or the end of February, right? So the logic here is either my maximum has to occur at a relative maximum, or it could be one of these beginning or end points of the interval. So what I'm going to do here is I'm going to go back and plug in those t values, and I get 230 for 0. We have this one already. And when I plug in t equals 28, I get $446.53. So my relative maximum in this case was not my absolute maximum, because what we just found is the best price to sell the stock is at $446.53 on day 28. So what that means, right, is we started on day 0, came back up to a maximum, and at some point we hit a minimum and continue to decrease, and here's the point 28, comma 446.53. And here's, of course, our 5 halves. So my absolute maximum, the absolute highest price, does not have to be the same as the maximum I found by my first derivative. So we already have this idea of justifying a relative maximum or a minimum. All we have to do is say that the derivative changes signs. For an absolute maximum or a minimum, we have to check values now. So this is sort of more information than just finding a relative maximum or minimum. This is called the candidates test. And our justification then can be a table. So we can do something like we did above. We have 0, 5 halves, and 28. And the important part here is here's our relative max, and here are our endpoints of our interval. Okay. And then you can write something like this. S of t has a maximum of blah, blah, blah at t equals blah, blah, blah by the candidates test. And your justification then is your table of values. All right, so where we can use this type of logic is in our good old-fashioned rate in, rate out problems. So we have water being pumped into a tank and draining out of a tank. Here we have a rate out, right, is b of t. And then my rate in, here we have water being pumped into a tank at a constant rate of 10 liters a minute. I'm going to call that p of t for pumped. And I'm going to say p of t is just equal to 10. So that's a constant rate in. Notice we also have this initial condition. We have 20 liters of water in the tank at time t equals 0. I'm going to call that w of t for water level. So we're going to say w of 0 equals 20. And that's going to be my water level in liters. And we're asked, what's the minimum amount of water in the tank at from t equals 0 to t equals 8? Well, what I would need to do here to get my critical values is I would want my rate in minus rate out to be 0. So in other words, I'm setting the derivative of the water level of the tank equal to 0. And that's going to be 10 minus a negative 4, all equal to 0. So this is my critical value condition. And if I had to solve this by hand, I'd be in a pickle because that's a hard equation to solve. But what I can do is I can solve this graphically. So I have my rate in minus rate out typed in. I set my window to 0 to 8 because those are the t values we're interested in. And I'm going to graph it. And notice when I graph it, we have a minimum. So to find that, I'm going to be like second calc 0, and that spits out 3.985. So there's my critical value, and that's a relative minimum at this point. The minimum amount means the absolute minimum amount. So we need to make a table here, right? And our table is going to be t versus w of t, because remember that's what we call the water level. And we're going to consider our endpoints and our critical value. We were given 20 in the text. Now we need to figure out how to find these two values. To do that, we need a function for w of t. And that's going to be an integral, right? It's going to be 20, the initial value, plus the integral from 0 to t of p of t minus b of t. So we have the starting water level plus the total change in the water level is my integral. And again, if I had to do this by hand, I would be in a pickle. But luckily, I know how to do this on my calculator already. So I'm going to use that fnint function, right? So math 9. And before I do that, I'm going to type in my 20. So 20 plus the integral from 0 to 3.95. 985 it was. And then I already typed in this whole mess. It's my Y1, right? So 11 point, we'll keep 3 decimal places, 117 liters. And then we're going to do the same thing again for 8, right? So I'm just going to copy and paste and change my upper bound to 8. And here I get 25.475. So here is my absolute minimum, and T is in minutes. So notice it's the same logic as our example on the first page, but because we're given these rate functions, we have to do a little bit of extra work here to find our values.